Hello everyone, welcome to another lecture about image acquisition and processing in LabVIEW. My name is Petar Atanasievich, and in this part of the course we will talk a little bit more about the image calibration and processing. So, in the beginning, let's talk about image calibration. Image calibration is a fundamental step in machine vision algorithms whenever an accurate measurement is required, and especially if you have a system that suffers from some type of distortion. For example, if the axis of the camera is at an angle in respect to the axis of the object, perspective errors will arise. Also, another type of distortion commonly seen in practice is lens distortion. This is a nonlinear distortion effect that occurs due to the imperfect camera lens. So why do we perform image calibration? Well, in order to find the relationship between pixel coordinates in an image and the real-world coordinates. That is the only way to perform measurements and obtain results in real-world units. On this slide, you can see an illustration of two different setups. In the setup on the left, no perspective errors will occur as the camera is right above the object to be imaged. The setup on the right, however, shows the camera is at an angle in respect to the object of interest. Thus, perspective errors will occur and the circular surface will be observed in elliptical form. One of the methods implemented for calibration and distortion correction is using a calibration grid. In this case, a calibration grid consisting of dots is shown. On the right, you can see the image of a cardboard line that is inspected using a machine vision system in a cardboard factory. On the left, you can see the calibration grid, imaged from the camera perspective. After learning the correction algorithm on the image of a grid, correction is performed on the cardboard image, and the corrected image is shown on this slide. Okay, so we will now do a short demonstration of image calibration using LabVIEW. First of all, open up a new VI. Go to the block diagram, and here, as you can see, I have pinned, and now accidentally closed, the vision and motion subpalette. So let's pin it again. Okay. We will be using it a lot, so it's good to be pinned. So go to the Vision Utilities subpalette and Image Management in order to find your iMac Create VI. It is used to create a temporary memory location for your image. So let's create a string constant here, which we will call the original, as in the original image. Okay. Afterwards, you need to open up your image from your file. So in order to do that, you need to use the iMac read file VI. Let's put it right here and connect these outputs and inputs. And of course, we need to create a file path control in order to specify where our image is. In order to display our image, go to the front panel. And there, right-click on the front panel, the Vision subpalette. As you have already learned, you can find your image display. Let's put it here, and let's enlarge it a bit. So, we need to specify the file path to our image. Let's choose our image, okay. And let's see, okay, I almost forgot to connect the output of the iMac read file VI to the image display. So now click Run, and you see only a part of the image. Right click on the image display and click Zoom to fit to see your entire image. So here you can see that this is the image of a grid in an imaging system that suffers from perspective distortion. Okay. In order to perform the image calibration, we will use an Express VI that you can find in the subpalette called Vision Express. The Express VI that we will use is the Vision Assistant Express VI that will, when put on the block diagram, open up the Vision Assistant. So let's wait a bit, initializing Vision Assistant. And here it is, the Vision Assistant. In the Vision Assistant, we need to, again, open up our image of a grid in order to develop our algorithm. Okay, so use your mouse wheel to zoom out. The Vision Assistant consists of a few main parts, like, for example, here, you can preview your images. If you have multiple images, your whole sets, you can move from the previous to the next. And this button right here enables you to make the image you see active. The active image is shown in this window right here. In the left corner, the bottom left corner, you can find your processing functions. Processing functions are divided into subpalettes. The first subpalette is related specifically to the image. The second subpalette is related to the color operations on color images, of course. The third subpalette is related to operations performed only on grayscale images. And the fourth subpalette is related to binary images, and it shows binary operations on images. This subpalette is especially interesting for us as it contains machine vision functions, and the last subpalette is related to identification functions like optical character recognition, particle classification functions, barcode readers, and of course 2D barcode readers, data matrix readers, etc. Okay. So the last part of the Vision Assistant is seen right here, and that is your script. So you can there you can see your script, your algorithm that you're making. Okay. So in order to perform the image calibration, go to the first tab, the Image tab in Processing Functions, and scroll down to find your image calibration function. When you click it, here you will see your options. So you have two tabs. Currently in Calibration Data tab is empty, and the Main tab enables you to do a new calibration. So let's click on the new calibration, and a new window pops up that enables you to choose the type of calibration that you want to perform. In our case, we will use a distortion model grid calibration. So choose this and click Next. And here you can choose the image on which you want to create your calibration model. So you can acquire a new image, or you can specify the image, you can select the image that you already have loaded. So let's do that and click Next. Here is where all the fun starts. So we need to zoom out in order to see our whole image, and as you can see, all the dots in our calibration grid have turned blue. What does that mean? That means that the automatic algorithm of the Vision Assistant already found all the dots that are needed to perform the image calibration. So if you want to do this manually, you can always specify the options right here. So you can specify if you want to look for dark objects or bright objects, if you possibly have bright dots in your calibration grid. You can choose the thresholding method. We will be talking about thresholding methods in one of our next videos. So let's leave it to this local thresholding method. And of course the kernel size and region of interest size. And here you can specify a few more options. So is it a valid dot area with a minimum limit and a maximum limit? You can specify the limits here. You can choose if your dots are of valid circularity, and you can choose the option if you want to ignore the objects that are touching the region borders. So sometimes the image will take up the whole area of your CCD sensors, the grid image, so possibly you want to ignore the objects touching, the dots that are touching the region borders. Okay, we will not do anything. We will just use the automatic setup here and click Next. So here you need to specify the parameters of your grid. Why do you need to do that? In order to perform real-world measurements. So we've already talked about this. Here you need to specify the distance, the X spacing and the Y spacing of your dots in the grid. And let's say that the X spacing and Y spacing will both be equal and equal to 1. And let's not choose 1 pixel, but let's choose another unit. Here you go. We can choose that they are distanced 1 centimeter. So they are distanced 1 centimeter apart. So let's click Next. Here it is. It is learning the template now. And as you can see, these are the calibration results for our image. And in the image itself, you can see little arrows, little vectors that are specifying where in the new image will the dots be moved next. So in order to see our corrected image, let's click Next. Okay, so here it is. This is the corrected image that we will use that we could use to correct the images of the objects that are imaged by our machine vision system. So you can specify the calibration axis here. We will not do anything here, but if you want, you can choose if you want to specify your calibration axis reference mode as the origin and angle or origin and x-axis point. So we will just leave it as is. Let's click Next. Here are the parameters that we are getting from our calibration model. So this is the summary. And that would be it. Let's click OK. Okay, so let's call this one calibration 2.png. So let's click OK. And we have a saved template. One thing I forgot to mention is defining the region of interest. So let's edit the grid parameters. Okay, zoom out again. So if you do not want to use the entire grid you have in your image, you can select a small region of interest, a rectangular, in this case, region of interest, and the dots that will be analyzed will be only the dots that are inside the region of interest that you have specified. So let's make the region of interest our whole image. Okay, so that would be it, and all the dots are once again blue. Okay. So everything else should stay the same. Great. So here you can see the calibration data of your calibration template. And the only thing left to do is click OK. OK, so the next step is choosing the image correction function. This function will perform the correction of perspective distortion based on the template of a grid that is obtained by this image calibration function. So that would be it, almost. We could, if we wanted to, select the inputs and outputs of our Vision Assistant VI that we are going to create. So we already have selected the image source, the destination image, of course the error terminals, and the destination image out. We could, if we wanted to, select the file path calibration access info for the image calibration 1 function, or the image correction function. Of course, we could select the inputs that are related to this function. We are going to leave this as is. Let's go back to the Process Images tab and let's click Finish. So now we should wait for our Vision Assistant VI to be created. So we do not need this to be connected. So this is our original image, and we need the memory location for our processed image. So we will just copy this. We will call this one processed. Okay. So this image will go, this memory location will go into the image destination. The image source is this image, and of course we need another the image display to display the processed image. Okay, let's connect this one to the output of the Vision Assistant. So for the image of a grid, it should be quite simple. We've already seen this result, so here is the corrected image. But let's choose another image that is obtained using the same imaging system. So it has the same perspective distortion. Let's run this. Okay, so here is the input image of a cup, of a plastic cup. And as you can see, here this circular area isn't exactly circular, it is more elliptical. And by the means of the template calibration in the Vision Assistant, does the image correction, and here is the corrected image that you obtain. So as you can see, this elliptical shape right here became very much circular in the end. So that would be it.